Hello friends, welcome to the Digital Electronics Practicals of FY BSC IT Semester 1. So here we are going to discuss about the basic logic gates and their ICs and how to interface these ICs. So the first practical is about study of logic gates and their ICs and the universal gate. So the logic gates are AND or NOT as they are written here. Amongst that there are some basic gates and then there are some combinational gates. These are the IC numbers that are used for this AND gate, OR gate, etc. So we are going to implement these gates on a breadboard in terms of circuit.
Logic gates are basically the building blocks of any digital system. They are basically the electronic circuits which have one or more than one input and one output. It is not necessary that they should have one output always. They can have multiple outputs as well. But the relationship between their inputs and output is based on certain logic. And that logic makes the different gates like AND gate, OR gate, NOT gate, etc. 0 volt is considered as logic 0 or bit 0, and 5 volt is considered as logic 1 or bit 1. Similarly, if they produce the output which is around 0 volt, then that will be considered as logic 0, and if they produce 5 volt or around 5 volt, it will be considered as logic 1 or bit 1. So in general, the output that logic gates give is 1, but in special cases there can be multiple output bits also can be produced by such gates. One thing to note here is that there will always be a time delay between the inputs given and the output produced. So this is how the logic gates can be studied. The next gate is a NAND gate. So NAND gate can be implemented using IC number IC7400. So this NAND gate is actually the combination of two basic gates, that is NOT and AND gate. So this NOT and AND gate are the basic gates, and this NAND gate is formed by putting them into the series. So how it is built or how it is designed. So AND gate is negated for the output, and that's how the NAND gate is created. So for NAND gate also, the number of inputs that are required are minimum 2 inputs. So these 2 inputs are given in the form of A and B, and then this NAND gate will work. So this is AND gate where A dot B will be calculated, and then it will be inverted, and that's why the output is shown like this: Y is equal to A dot B bar. So whatever the product of AND gate will be yielded, that will be inverted by this NOT gate, and that's why the logic gate name is NAND gate. So here is the truth table. Since we have two inputs here, so these two inputs can have possibly 4 different combinations, that is 0 0 0 1 1 0 and 1 1. So in terms of AND gate, the output should be 0 0 0 1, but since it is negation of that AND gate, the output will be simply inverted. So 0 will become 1 and 1 will become 0. So for an AND gate this was 0, but for NAND gate it is 1. Similarly, for AND gate this was 0, for NAND it will be inverted to 1. So in this case, only in case of this last combination, that is 1 1, the output will be 0. For all other combinations, the output will be 1. Here is the pin diagram of IC number 7400. So if you are going to hold the IC with this notch at upside, then this first 7 pins will be on the left side and the next 7 pins will be on the right side. So the 7th pin is ground and 14th pin is positive or plus VCC. Then like OR and AND gate also, this NAND gate also have 4 gates into this IC. So first and second pin are the inputs, third pin is the output. Similarly, fourth and fifth pin are the inputs, sixth pin is the output. And similarly on the right side you can see there are two more NAND gates. So if I want to implement this NAND gate, I need to provide input at first and second pin, and I need to check the output at third pin. So to this third pin I can connect LED and I can check the different combinations of inputs. So we will see how this NAND gate can be implemented on the breadboard.
So let us see how to implement NAND gate. So to implement NAND gate, we require breadboard, power supply, ICs, LEDs, jumper wires, and the register. So let us see how to implement this NAND gate. So NAND gate is called as universal gate. This NAND gate can be implemented using IC number 7404. So this IC, if you're going to hold like this with notch upside, you will find 7 pin on one side and another 7 pin on the other side. You need to count the pin number 1 from this side. So this is pin number 1, this is pin number 2, and hence this is the 7th pin. This is 8th pin, 9th pin, 10th, and so on. This is 14th pin. This 14th pin is to be connected to the positive or plus VCC, and the 7th pin is to be connected to the ground. So I'm putting this IC in the breadboard like this, and then I'll connect this negative and positive supply from the battery. Now this battery provides 9 volt, but for this ICs I require 5 volt. So I'm using this register in between. So this register is of 220 ohm right now. You can use up to 1 kilo ohm resistance to minimize this power supply of 9 volt to somewhere 5 volt. So now, since I have placed this register in between this power supply, here I will get hold this positive power supply, which is less than 9 volt, which may be somewhere around 5 volt. And for this whole horizontal line I got ground connection. Now first of all I will be connecting this 14th pin of the IC to the positive side and this 7th pin of the IC to the ground. Now the output can be seen at the LED. So to identify LED's positive and negative side, the leg which is longer is the positive and the leg which is shorter is the negative. Also you can check the small filament is the positive and broader filament is the negative. So you can place this IC, so you can place this LED somewhere here like this. Now for a NAND gate, the first and second pins are the inputs. So I'm using these 2 pins for the inputs. Let's say my input 1 is in blue color and input 2 is in green color, and I'm using this yellow colored pin for output. So my third pin of the IC is the output. So that output should go to the LED, and LED's another leg is to be connected to this ground. Now I will be verifying the truth table of NAND gate. So the truth table of NAND gate is, for any one input 0, the NAND gate will glow. So right now it is not glowing because both the inputs are open, that is on. So if I'm going to make any one of this input 0 or this negative, this will glow. So here you see one input is negative and the other is positive, so it is glowing. If I'm making both the inputs of this to the negative, it will still glow. If I am exchanging this as 0 and this is 1, it will still glow. But if I am going to make both the inputs high, the NAND gate will be low. So this is what the truth table verification for the NAND gate. Now I was using this first 3 pins, wherein first 2 pins were input and second pin was, third pin was the output. Now I will be using this remaining group of pins, that is 4th pin and 5th pin as input and 6th pin as output. So I'm simply exchanging this wire. So this is the 6th pin is the output and now I'm connecting these two input pins here to the 4th and 5th, and now I will be again verifying the truth table. So as I said, for the truth table, if any one of the pin is 0, the NAND gate will glow. So if any one of the input is going to be 0, the NAND gate will glow. So one input high, one input low, NAND gate will glow. Exchanging these inputs, this input low, this input high, it is still glowing. If both the inputs are going to be low, it will glow. When both the inputs are going to be high, the NAND gate will not glow. So this is how the NAND gate can be implemented on a breadboard.